Hi teachers, I wanted to make sure that I have addressed 12C and 12D. These are two new teaks that we're going to cover in our next unit. Some of you have already started planning for it. At the end of this video, or by the end of this video, I want to make sure that I've answered this question, what do students need to be able to do? So before we begin talking about sequences, just let's define two of those terms up there. A sequence is a function whose domain is a set of positive integers. So right there, a sequence is a function. That should not scare us. I think that actually should make some of us feel comfortable. And then terms, when they say terms, terms are numbers in the ordered list. So let's talk about arithmetic and geometric sequences. Okay, so let's talk about sequences. And I'm going to apologize ahead of time. I know my handwriting is awful, but it's even more awful today because I'm having some computer issues. For some reason, it's really jagged when I'm writing, almost like my computer's fried or something. Okay, so let's just take a sequence. I'm going to take the first few terms of a simple sequence. That's an 8, folks. Okay, 4, 6, 8, 10. So immediately we start to look for a pattern. Now when we look at a sequence, these are in position. The first term, second term, third term, fourth term, all the way to the nth term. Okay, so we call these A sub 1, A sub 2, A sub 3, and this is all new for your kids. They have not seen anything written like that before, so this is something to get used to. Something they need to see. So if I'm looking at this pattern, it looks to me like each time we move to a term, we add 2. Really simple pattern, right? We call this our common difference. Okay? And that common difference is represented by D. In this case, D equals 2. We always look for the pattern in the form of addition. Okay, so for our arithmetic sequence, I'm saying this is always addition. If this were to be a pattern where it was backwards, 10, 8, 6, 4, we would say this is plus negative 2, not minus 2 each time, even though that's how the kids are going to see the difference. That will make a difference when we start talking about geometric. Okay, so with this pattern, we see A sub 1 plus that common difference, which was 2, A sub 1 plus 4. So if I went from here, this is plus 2. If I went from that first term, plus 4, plus 6. And the reason I'm saying that is because if I look at this last term here, A sub 4, the fourth term, by the time I get to this fourth term, I've added 2 3 times. Okay, so when we start talking about a formula for the nth term, so we write a formula for the nth term, we say this would be A sub 1. I'm going to write a generic one, and I'm going to write the formula for this sequence, A sub 1 plus, okay, and then we see that common difference, 1 less than the number that we are on. So if I'm on the fourth term, I've only added it 3 times. If I'm on the third term, I've added that difference 2 times. So I've added that common difference in minus 1 time. Okay, so really I'm writing the function this is 2 plus 2, and this is the function for the nth term. Okay, this is what your book is calling the explicit formula. Do the kids need to know the word explicit? No, that is not vocabulary in our TEKS and is not referred to that way in some of our other textbooks. So if you're using a calculus textbook, pre-cal textbook, it's not referred to it as explicit. So you just need to know this is the function that produces this sequence. Okay, so that's our explicit. That's what your book is referring to as explicit. Kids don't need to know that vocabulary, but you certainly want to refer to it the way the book is telling them in case that's how the directions word it. Now, recursive is always based on a previous term. So what we just saw is based on the position of that term in the sequence. Recursive is based off of the previous term. Okay, so I want a formula for the nth term based on the term before it. The term before it would be one less than that. Okay, so if I were going to say I want to know how to get, oh, I'm sorry. Big little mistake there. Okay, if I want to say at a sub 4, how did I get here from the last term? Okay, well, from the previous term, from 8, I added 2. So from each previous term, I'm just adding 2. So that's what I'm going to say here. I've just added 2. The nth term is the term before it plus 2. That is your recursive formula. Okay, now let's take a look at a different type of sequence. So instead, let's talk about geometric sequences. Let's say instead we have this formula. Okay, so first term, second term, third term, fourth term, all the way to the nth term, a sub 1, a sub 2, a sub 3, all the way to a sub n. Okay, so for this pattern, what we see times 3, times 3. Okay, each time it looks like we're getting multiplied by 3. That we call this pattern with multiplication common ratio. We represent it with R. Common ratio is always in the pattern of multiplication. So if we see these numbers backwards, if we had a pattern that was 54, 18, 6, and 2. There wouldn't be any dots, sorry. Okay, this going backwards, we would say this is times 1/3, not divided by 3. Okay, our common ratio is always in the pattern of multiplication. Okay, so we would see the first term times 3. By that third term, I've multiplied it 2 times. By the fourth term, I've multiplied it 3 times. So when we are putting together our formula, we say this is a sub n, first term times the common ratio, n minus 1 number of times. Okay, so that fourth term, by the fourth term, I've multiplied 3 separate times. So for this formula, a sub n equals, our a sub 1 was 2, common ratio was 3, n minus 1. Okay, and this is what your book is calling the explicit formula. So this is our function of n. Based on its position, this is the pattern that we see in our sequence. Okay. Now, let me bubble this. We're done with this guy. Let's talk about recursive. So recursive would be from the term previous. So a sub n. What would I have to do to the term previous to end up in our term? So if I look at that fourth term, what did I do to 18 to get 54? Well, I just multiplied it by 3. What did I do to 6 to get 18? Well, I just multiplied it by 3. So from the term previous, I'm just multiplying by that common ratio. I really wish I could write today. I apologize. I'm going to have to get a new tablet, I think. Okay. So there's our recursive. Recursive is always based on the term previous. Okay, so let's go back and look at our TEAG. Okay, so for this 12C, identify terms of arithmetic and geometric sequences when the sequences are given in function form using recursive processes. That's the one that probably ties us up right here. What are they actually going to have to be able to do? Identify terms. 12D says write a formula for the nth term. Well, we just did that. We just wrote formulas for the nth term, and this one does not say recursive. So they do not need to generate a recursive formula. They need to do exactly what we did right here. And right here. Okay, and for our recursive defined formulas, Let's look at two examples for A12C. A sequence is defined recursively, write the first 5 terms. So this first example, this is an arithmetic sequence. I see an addition happening here to the last term. So I know this is arithmetic. So we start with our first term. It's already given. A sub 1 equals 2. A sub 2 is dependent on that last term. So this would be A sub 1 plus 3 would be A sub 2. 3 plus A sub 1, so in this case this is 3 plus 2, which is 5. And then same for that third term, it would be the last term plus 3, which is 8. And so we get our pattern here. This is 2, 5, 8, 11, 14, and that's our first 5 terms, and so we're done with our arithmetic. Geometric example, we've got A sub 1 is 5, and our pattern here is 2 times the term before it, so in A sub 2, this would be 2 times the one before it, which was 5, which is 10. We want to show this process pattern for our kids so they know what's happening and where I'm getting these numbers from. So 5, 10, 20, and we can do this a few more times. A sub 4 and A sub 5. Two times 20, 40, times 40, 80. Sorry, my computer's slowing down more and more, so I'm getting a little messier here. Okay, so this is what they need to be able to do with that second teak that we saw, writing the terms from a recursive formula. Okay, looking at your calculator then, in your calculator there is an option to do this. If we're going to just choose calculator here. Okay, in our menu, if you go to statistics, you do have a sequence option under list operations. In that sequence option, it's going to want you to put the sequence first. So let's start with 2x plus 2. That was our arithmetic we just saw. Okay, then it's going to ask me for the variable, which is x in this case, the starting place, and then how many terms I want to go to, let's say the 5th term in that sequence. And it's automatically going to count our x value in ones. So I want to count by the first position, second position, not the 1.5 position. So we don't have to worry about that. So this gives me my sequence starting with 4. That was the arithmetic sequence we just saw. Let me do that again, and I'll do it with geometric. So it's under statistics, list operations, sequence, and let's see, our second one was 3. Oops, did I click off of it? Okay. 2x minus 1. Also variable x, we'll do the first 5 terms. And there's the sequence we just saw, first 5 terms. Okay, so you can also show your kids how to find your sequence by plugging it into your TI Inspire. Okay, and what I've showed you in here for sequences on the TI Inspire was just with your explicit formula, your function formula. So for your recursive, they're going to do it the way we just saw. They're going to have to know the pattern in the recursive formula. Let me go back. Oops. Which means they'll be given the first term and the recursive formula and have to write the first few terms. This is a pretty good example. You usually ask to write the first 5 terms. You can start with examples where they find 10 terms. Either way, they're going to be given the formula if it's a recursive sequence. Okay, that's all for our video, so I would really love to get some feedback from you. So, if you would pause and type in this link, I would love to hear back about how helpful the video was, and if there was some need for Google Hangout, some conversation, maybe we do this in Google Classroom, but fill out the form. I'll give you some ideas, and maybe you'll give me some ideas. Thanks for listening.